Hi, today I'll be demonstrating the proof of concept for task 1.1p, the moon robot simulation. Uh, the goal of this task is to simulate a robot navigating a square grid on the surface of the moon. The robot can be given command to place itself and move, rotate, and report its current position and direction. And but it must be never fall off the grid. And in this task we have come here we have come out, and also there are a couple of thing is given to constraint, uh, the robot must be ignore all command until they is dropped on the map, and also the robot must be not perform any invalid moves, and map size should be 2 by 2 2 by 2 and no longer than 100, so and so on. So let's go to the code. So first of all, we have to define the uh, modules. In these modules, we have defined the direction and robot class. In this direction, uh, we can enumerate the north, east, south, and west. This enum represents the four cardinal direction, and it used to control the rotation and movement of the logic across the application. So let's go to the robot class. In this class, what we are doing is robot has position. It is private integer price xy. The robot has a direction and boolean for whether robot is placed on the map or not. And the grid size define the sequence boundary of the moon grid that will be the grid robot will be moved. And this is a constructor, and this place method is responsible for initially positioning the robot on the moon grid and setting the direction it facing, and it ensure that the robot is only placed within the valid grid boundaries, and the robot internal state is updated correctly. While placing the robot, it should be less than the grid size and opposite like that. And let's move the move command. Here we are doing is move should be in the given direction, and it should be increase the coordinate by 1, that we are doing here. Then according to the direction x or y will be changed. Then I will validate, like if it is going out of the grid, then it will return false, and move will be not effect like we are creating a new variable, so otherwise the class position of the robot will be update, otherwise not. So let's move to the uh, left method. Left method is responsible for rotating the robot 90 degrees counterwise without altering its current position on the grid. Before performing the rotation, the method first checks whether the robot has been placed on the grid using the I place flag. If robot hasn't been placed, the method exits and return false, ensuring that commands are only executed after valid placement. If the robot is placed, the method update its current direction by subtracting 1 from the enum value of the direction using module arithmetic, instead of subtracting directly, and it adds 3 and then take the result module for this ensure the proper background from the north to west. Finally, the method return the true indicate that the left rotation was successfully complete. This function is essential for enabling the robot to return and navigate the grid properly without moving forward. And also the right method is similar. I'm not going to explain this in here. And in this report method, the purpose of the report method is to display the robot current position and direction if it has been placed on the grid, and if the robot hasn't been placed, and it return the message saying it hasn't been placed yet. So let's go into the command processor. In this command processor, the command processor class is responsible for interpreting and executing the user command like place, move, left and right, and the report for the robot. It takes the input as a string and process it, and then call the corresponding method in the robot class. It also handles the input validation and ensuring the robot only respond to valid and properly formatted command. This acts as the middle layer between user input and robot behavior. Then this execution is doing string will be split into a part. According those part, we will get that command. Then, if this place command is given, we will check whether other parameters are they are like x and y, and then direction, and then we will split again that part. Then according to that part, we will check it is correct. According to that, we will use the robot instant to place the robot and call the move method of the robot and return the successful or failure message depending on whether the robot was placed and move is safe. And here the default is return an error message for any invalid command. So let's go to the main program. This is the main class. This is the starting point of the program, and what we are doing is the first of the welcome message. And this part of the main method is the starting point of the Moon Robot Simulation Console Lab. In first, welcome the user and then ask them to input the size of the grid the robot will be moved on. Here we use while through loop for the enter the size map. The while loop is used to continuously prompt the user until they enter a valid grid size between 2 and 100. If the user enter valid input, meaning a number between 2 and 100, the program successfully passed the validation check. The invalid, so the input validator dot validate grid size method confirm the input uh, within the acceptable range and store in the grid size variable. As the result, the program enter the else block where the break statement is executed. This causes the while through loop to exit, meaning the program will be no longer from the user for input. From there, it processes to create the command processor object using the valid grid size, which set up the environment for the robot simulation. After that, we will be main loop will be executed until exit command is given, and uh, inside the loop, the user is prompted to enter commands such as place, move, left, right, or report. The input is read and trim and remove any extra space. The command is then passed to the execute method of the command processor, which interpret it and perform the corresponding action. The result or message returned from the command execution, whether its success message "Oh, error" is then display on the console. So let's run the program and see the result. I already start the program. So first of all, I enter the invalid number. So you can see the here see the message invalid map size. So then now I'm going to enter the valid number. You can see the robot is ready. Then please enter command. So now I enter command move. But move not be permitted until the robot is placed. First of all, we have to place the robot. So I give X coordinate to 1. No, before that, we have to type place X coordinate to 1 and to Y coordinate to 0. And now I give the direction to north and enter. So now you can see the robot placed successfully. So let's see the report. Here you can see the report. So now I'm going to exit the program. So this is the end of my demonstration. Thank you.